In this video, we will learn how to interpret scatter plots and how to identify correlations between data sets. And later we're going to learn how to use lines of fit to model the data, and we're going to do that using Desmos. Okay, so first, a scatter plot is a graph that shows the relationship between two data sets. The two data sets are graphed as ordered pairs. Okay, so ordered pairs are those XY pairs, where one data set is the X's and one data set are the Y's. And we graph that in a coordinate plane. Okay, so those are those XY axis. And we plot all those XY pairs. And scatter plots can show trends in the data. So if I was looking at this, I could see, oh, it looks a little bit like maybe there's a line that could fit through that. So our first example is on interpreting scatter plots. It says the scatter plot shows the amounts X in grams of sugar and the numbers Y of calories in 10 smoothies. So our X is sugar in grams, and it's down here, and Y is calories. Our question is, how many calories are in a smoothie that contains 56 grams of sugar? So I find where 56 grams of sugar would be. It would be halfway between 54 and 58. And I follow that line up until I get to here. There's a point there. And then I follow that over, and I found 270. So there are 270 calories in a smoothie with 56 grams of sugar. Okay, the next question, how many grams of sugar are in the smoothie that contains 320 calories? So I find 320 on the calories and follow my line over till I hit a point, and then bring that line straight down, and I found 70 grams of sugar. So there are 70 grams of sugar in a smoothie that contains 320 calories. And actually, it would probably be better to say in the smoothie that contains 320 calories, because we're talking about a specific point on here. What tends to happen to the number of calories as the number of grams of sugar increases? Well, it looks to me like when I look at my data, the ones that have the most grams of sugar tend to have the most number of calories, and the ones that have the least number of grams of sugar have the least calories. So I will say as the grams of sugar increase or go up, so do the number of calories. Okay, so here's two for you to try. How many calories are in the smoothie that contains 51 grams of sugar? And how many grams of sugar are in the smoothie that contains 250 calories? Here are the answers. Note that 51 grams of sugar, that's not quite halfway in between. It's going to be closer. So you have to follow it up, and it's going to lead to this point. And then the 250 calories is going to lead you over to this point, and that is going to lead down to the 52. All right. So now looking at those relationships, we're going to learn a new word. It's called a correlation. Okay? We're going to be identifying correlations between data sets, and a correlation is just a relationship between data sets. Okay? So if things are correlated, it's just saying there is a relationship that happens between two things. It does not mean that one thing causes another thing, just that as one thing happens, this other tends to happen. So an example of this is in the summertime, we would say that as ice cream sales increase, so do shark attacks. But nobody thinks that shark attacks makes people want to eat ice cream, or that people eating ice cream makes sharks want to attack. It just happens that when it's nice outside and nice and warm, there's more people in the water, so there's more likelihood of a shark being able to attack. And also, when it's nice and warm out like that, people tend to want to buy more ice cream. So those two things are related, but one doesn't cause the other. Okay, positive correlations. As X increases, Y increases. It just looks the same as a positive slope. Okay, the data is clustered, whereas one goes up, the other goes up. Okay, so it looks like a positive slope. So it looks like. Okay, a negative correlation, as one goes up, the other goes down. Okay, so it looks like a negative slope. And the last one is no correlation. Sometimes two things just don't seem to be related. And no correlation just kind of looks like this cloud of random dots. As one thing goes up, it doesn't seem to affect the other one at all. Okay, so there's no pattern in that. So here's two problems to try. We have this relationship between a person's age in years and the number of vehicles that they have owned. And because when the person's age is increasing, I can't really see a pattern between what's happening with the number of vehicles owned, then this is an example of no correlation. When there doesn't appear to be a pattern. Now the next one, temperature and coat sales at a store. As my average daily temperature is increasing, the coats sold per day is decreasing. So when the temperature was low, like 35 degrees, there was a lot of coats sold each day. And when the temperature was high, there was not so many coats sold per day. So this is an example of a negative correlation. Okay, the last two U tries, I'm actually going to demonstrate how to do one. We're going to do number 4 together, and then you're going to try number 3 on your own. To make a scatter plot, we need to put our data on here. So my X values go along the X axis, and so this is temperature down here. And I have to organize all of these numbers have to go on there. A trick we can use is to use this little squiggle line to say we're not starting all the way down at 0. Our lowest number is 68 and the highest number is 92. So we need to find a way to space those evenly along here. So there are 9 more boxes besides the one that I skipped, and 68 and 92 are 24 apart. So I think I could count by 3s. So I'll start at 66, 69, 72, 75, 78, 81, 84, 87, 90, 93. And then I'm going to do the same thing for my y-axis. My y-axis is attendees. And that's in thousands. So when we see a number like 4.5, that doesn't mean 4.5 people attended something. That means that 4.5 thousand people attended, or 4,500. Okay, and I have to find a way to organize this on my y-axis and spread it out evenly. My lowest number here is 1.7, and my highest number is 5.5. So I think I'm going to put another one of these in here, and I'll start at 1.5 and then 2 and 2.5 and 3, 3.5 and 4, 4.5 and 5, 5.5 and 6. Okay. And then I have to plot each of these as data points. So I find where my temperature is 82 degrees, so somewhere around here, and follow that all the way up until I get my attendees at 4.5. So I put a dot around here, and then I get where the temperature is 78 degrees. Okay, so I'm plotting this pair now. The temperature is 78 degrees, and the attendees are 4.0. And then the temperature is 68 degrees, so, and the attendees is 1.7. So that's somewhere around here. And 87 and 5.5 is around here. And keep going, plotting each of those points approximately where they go. So 71 and 2 and 9/10 is around here. 92 and 4 and 7/10 is around here. 84, 5 and 3/10 is around here. Now as I look at my data, it looks like as my temperature is increasing, my attendees is also increasing. Or if I tried to draw a line through my data, it would have this kind of uphill slope. You do not have to draw a line through it, just like to see the trend. So this is a positive correlation. Now it's time for you to practice making your own scatter plot. Remember to label your X and your Y axis. Decide on what you want to count by on each axis. Decide whether you need to use one of these because your data doesn't start right at the early numbers. And plot each of your points and decide whether this data has a positive correlation a negative correlation or no correlation.